Further, this control unit also connected via USB port to your laptop, and you can use the software interface for further analysis and detection purposes. So I'll just try to launch the software which comes with this package. Once installed, you can just launch this software and the user interface shall look something like this. Okay, so once this control unit is connected to your laptop via this USB port, you just click on this connect button and it shall connect automatically, right? So let's get to the basic how to use this device. So let's get familiarized with the control unit button and the user interface. So this 001 will indicate the number of tabs that we have labs, and this will show the maximum value of audio signal or the input signals from the mic and piezoelectric sensors, which is inbuilt in this handheld device. If I can zoom it, you can see three openings for this piezoelectric and audio frequency mic. Okay, and this will this is the threshold value or the set value above which means if the signal goes, the tap signal goes above which detects a clear delamination or debonding of the composite material. You can set up to two set values or threshold values, and you can also change it, and you can also customly change this 300 millivolt or 500 millivolt. You can set whatever you may like, right? And this I will tell the other function of this all of this in a moment. Before that, let's familiarize with the software UI. So here is the connect button. Once click, it will connect, and the disconnect button will highlight. I can show you again. See, this is now, this connect is active, this is not active. Once we click on connect, it will connect with this control. The laptop will connect with this control unit. Okay, so there are few UI things that we must know. This is the file path where the captured data file shall be stored. This is the serial number of the tab. This is the vertical division of this graph like thing. You can set 300 millivolts or 100 millivolts and whatever you may like as per your application, right? Area marker will show the some guiding lines that you can manually set. If the maximum value is above this set value, you can, means it's easy to recognize that this is a debonding or this is not okay, right? So this is just for clarity purpose. This vertical division from here to here will show the data from the audible mic, and this is from the piezoelectric sensors. Both are in millivolts, and this is piezoelectric sensor trigger value, the minimum threshold value above which the piezoelectric sensor will pick up the value. Means right now it is set at 20 millivolt. If the output signal from the piezoelectric sensor comes to be below 20 millivolt, it will not pick up the signal. So it's application specific. So that can be also can be set manually. This will show legend. Cursor is just it will show you the value once there is a graph. I'll show you in a moment. Okay, so okay, now let's take a reference value for a good portion where there is no delamination or no debonding of the composite material. So we can take that by, okay, let me just, by clicking this hit button. Okay, I'm going to hit it. As you can hear the tab and the graph is over here. So let's say for a good part of the composite material, this mic value comes to 191, and the piezoelectric, from the piezoelectric sensor it come to 110 millivolts. Okay, let's consider this as the value of that portion where there is no delamination or debonding of the honeycomb structure. So let's take around 200 as a set value and 300 as the set value from our this graph, and we can now check the whatever the portion we may like to inspect, right? So just long press this trigger for 0.5 seconds and it will start automatic tapping. Now see as I can move, if there is no delimitation, it will come with green signal, and if there is delamination or debonding of the honeycomb structure, it will come as NG or no good, or there is a delamination or debonding of the honeycomb structure in the composite material under consideration. Okay, so I do not have any specific specimen to show exactly, so that's why we are getting some garbage value, but if you can observe closely, it's not very, if I can come to my initial position, the values are not very far away. Okay, and the number of taps is continuously recording and increasing in the serial number, as you can see. Okay, so let's stop this by pressing long press, right? So now let's learn what this graph, both of the graph basically indicate. So these are the output from the sensor, and it's drawn for time period of 2000 microsecond, from 0 to 2000 microsecond. Same for this piezoelectric, and for this why this null point or 0 point comes in somewhat away from this 0 coordinate is basically due to, read this from the manual. After the tapping, when the piezo sensor voltage reaches the trigger level, what was the trigger level? It was 20 millisecond. Let's set it to 50 millisecond, then it should shift something away from it. Let's take two case for understanding it better. At a piezoelectric trigger at 15 millivolt and 50 millivolts. Okay, so let's start with 15, and I'm going for a single tap. Okay, so as you can see, this for the same part of the composite material, the null point comes on the extreme left. Let's try with, let's say, 60 millivolt. Okay, null point, then null point should come somewhere in middle or left side of the middle. Let's try that. See, the null point has been shifted by some units. Okay, further, using this cursor norm button, we can read the value at each of the locus of the graph points, at each of the point where we this value will show here, the time and the audible frequency amplitude varying with the time. As we can see, it's varying the time as well as the this mic millivolt is changing as we go through. See, this is the null point, and it should when I am on null point, it should come to 0. Yeah, around 2 millivolt. Okay, for better clarity, you can adjust the vertical scale divisions as per your requirement. So when we set 300 millivolt, the amplitude will increase. Actually, the amplitude is not increasing, the scale per division is increasing. That's why the height becomes larger. Okay, amplitude becomes larger. For 100 millivolts, it will be something like this. Okay, for let's say any particular position or coordinates on your specimen, you can copy the graph of the individual tab, and if you want to paste it somewhere, let's say in a word, you can do that. Just Ctrl plus B and the graph will pop up wherever you may like to paste. Okay, so this is one of the features. And during continuous tapping and detection or the inspection, this right side of the UI will show the maximum mic maximum and this piezo maximum of that tap of that graph. Okay, and we can set the set value from here as we already spoke about. So let's say if I set this to 100 millivolt and the second as 150 millivolt, and right now our control unit has one of the set value as 503 that we have previously. Just click on write and the same data shall be copied on the control unit, 100 and 150. Okay, so let's set it to 300. I think 300 should be optimum for our case, and push that data to control unit. Yeah, it's fine. Now let's start tapping. It's coming as OK. Here also it's coming as OK. But whenever we don't get the value near to our set value, a beep will come, as well as it will indicating as NG, and a red beep alarm will come in the control unit. We can also check the data from the control unit itself by pressing up and down data buttons. Yeah. These are all above the threshold value. Whenever there is good data, or the data which is showing there is no delamination or debonding, this green light will come. Let's go back further. We have plenty of bad data stored over here. See, maximum 325 millivolts. Okay. For each of the tab, we can also check the numerical data. Yeah. Over here, this numerical data values. This is the time in millisecond. These are coming in negative due to the obvious reason that we have discussed already. And the mic values as well as the piezoelectric sensor values that we have captured during our test, and it will go up to 2000 microsecond, because for each tab it capture data up to 2000 microsecond only. Further, for each tab, this software is creating a file at this directory, a separate file for each tab. We can just click this browse button, show folder, and I think we have how many tabs? 313 tabs. That means we should have 313 files in the Excel sheets. So let's check that. How many? 501. Okay. So some file was from the previous tests. So I have just tapped there is total 30 tabs. Now let's check the folder. We should have 30 files. 41 files. To reset the serial number to 0, just check and uncheck and check this, and it will initiate from 1, and it can store up to 999 data points. So let's start again to check whatever we were doing. See, now it's tapping rapidly, but you can see the serial number is not increasing. That's because it has checked with blank hit detect, right? So let's start again, and the serial number is increasing right now. Once you stop, it will detect the blank hit. So there is a inbuilt feature of it in. Okay, so how many tabs? 51 tabs. Let's check the show folder of this time. Let's see, 50 items. Okay, and this one is the 51 tab, which is not written. Once we tap 52nd time, the data from the 51st tab will return to the local drive of this computer. 52, as you can see. Now open the folder. How many? 51s tab. Okay. For this serial number of the tab, there is also option of manually naming the tab number. So after unchecking this autofill, I can tap and the tab number shall not increase. Let's say we get the data whatever we needed and we stop tapping, and we can just increase to 53, and the 52 data must be over there. There is also option of naming each tab manually. Once we get satisfied at a certain point after investigating it or testing using this tapping detector over the same point multiple times, okay, so that can be done like let's say this is the second tap. See, the graph is changing but the tap number is same, and we can save that each tap data manually using this Excel button, and file name will be created using the date, month, year and time as well as the serial number of the tap, and you can save it just manually. Okay, so these are the one of the things. We can also load the past data from this readout button and selecting the relevant tapping point. Let's say I want to check the curve of the serial number 23, and I just hit open and the graph will come. Okay, readout, let's randomly select anyone and enter. So I can also withdraw all of the tap data, means whatever the data that has been already been saved into the hard disk or the local drive by using this all at once, using this withdraw data and set start data transfer. See, all of the tab positions, and it's basically asking, do you want to delete the data in the unit? I can do also yes. Okay, now it should come to tab number 1. Okay, so this is basically showing tab numbers or point number, this mic sensor maximum amplitude, the Pmax yani piezoelectric sensor maximum amplitude, and the judgment whether there is a the lamination or the point where we have tabbed is okay, or there is delamination or debonding. The delamination or debonding shall be shown as NG, whereas if everything is okay, it will show okay, right? And it will it is automatically saved to the same location. Just click show folder and there is a file called result.csv. This is the point number, NMAX, mic max and piezoelectric max. A total of how many? 432 tap points. Now let's delve in details, further details. Total number of taps are 22. Auto filing is checked. Okay, now open show folder. How many? 21. Tap number 22. Okay, let's withdraw data, set start data transfer, no, the result.csv. Okay, result.csv opening. For tab number 1, NMAX 240, Pmax 1111.